one of my favorite places on Earth is one of the most beautiful parts of the Amazon basin that I've ever had the privilege of visiting. There's a national forest right next to the Tapajós River, and it's a place we've long studied in the central Brazilian Amazon. Inside the national forest, we've built a tower that allows you to walk up 150 feet into the air. As you walk the steps of this metal tower, you finally step out into the sunlight on the top of the canopy. You're surrounded by an ocean of green. And in every direction you look, you're seeing the vivid colors of the tropical rainforest canopy. It's really striking to me to be able to feel so immersed in that environment, from the forest floor all the way to the canopy. And if you're sitting there at sunset, when the macaws are coming into roost, and the monkeys are making their last calls for friends or food, it's a really peaceful and alive place. It just reminds us that there are fascinating things yet to discover on our planet.
Welcome to NASA's Curious Universe. Our universe is a wild and wonderful place, and in this podcast, NASA is your tour guide.
I'm a research scientist,
Earth scientist, project scientist
at NASA.
When you think of NASA, you might think of all the incredible mysteries of outer space. We're also pretty invested in another very special place. I'm Patty Boyd, and in this episode, join me on an exploration of one of the most fascinating places in the solar system, Earth. This April is the 50th anniversary of Earth Day, and we're explaining some of the ways NASA keeps an eye on our home planet.
Sometimes here at NASA, we like to say that every day is Earth Day.
That's Doug Morton. He's one of the many Earth scientists at NASA.
Studying our home planet has always been a really important part of NASA's mission. NASA has so many different ways to study our planet, and as a scientist, it's my job to think about which of those different measurements are important for the questions I'd like to look at.
Think of all the amazing parts of our planet. Earth is home to volcanoes, deep oceans, sprawling deserts, and growing cities. It's the only planet we know of that can sustain life. That's a lot to keep track of, and everything is connected. NASA's Earth scientists work to monitor and measure these systems so we can better understand how our home planet functions and how it's changing.
NASA's satellite data records really tell the story of our changing planet. In the last 30 years, we've watched the polar ice caps shrink. We've actually been able to estimate the amount of water that's been lost from glaciers and ice sheets by weighing water from space. We've been able to track changes in forests from natural disturbances like hurricanes or wildfires, or the expansion of agriculture that shifted production of grains and crops from places like the Midwest in the United States to the frontier of the Amazon basin. We've been able to track changes in our atmosphere that relate to how volcanoes put sulfate particles high into the stratosphere, or how the ozone hole has actually been shrinking over the time record of our satellite data. Each of these scientific discoveries really depends on having a knowledge of our home planet, as well as the information and the regular, carefully calibrated and collected measurements we take from space to track those changes over time.
Those carefully calibrated measurements can help scientists like Doug gather information about our planet and predict patterns for the future.
From space, NASA has a really unique role to play in terms of how we understand our home planet. Our scientists have designed instruments to be able to take measurements of our atmosphere, our oceans, ice cover, and vegetation. And as we put those pieces of the puzzle together, we're able to look at our entire Earth as a system, and all of its complexity.
NASA has a global view of living ecosystems, both on land and in the sea, something made possible by satellites. With that view, we can see the effects of our changing planet on the life cycles of things like forests and plants. We can even track wildfire outbreaks in remote areas, sometimes before first responders on the ground. NASA Earth scientists study all sorts of things.
One of my areas of research is how wildfires are changing our planet. Really, someplace on Earth is always on fire, and our NASA satellites are often the first to detect those fires and, of course, to track their changes. What do those fires mean for people living in communities close to the fire? Where does the smoke from those fires go? And how might it impact people living in cities far away, as well as the greenhouse gases that build up in our atmosphere?
We can understand a lot about Earth from space. We can use scientific instruments to help us learn about things like air pollution. Anne-Marie Eldering, a scientist at NASA's Jet Propulsion Laboratory in Pasadena, California, works on one of those tools.
A lot of folks know about the NASA work focused on solar system and Mars and planets, and they don't realize how much we're doing about our home planet. The International Space Station has been flying around our Earth for quite some time, but people maybe don't know too much about what's going on up there. I'm the project scientist on the Orbiting Carbon Observatory 3. That's an instrument that's installed on the International Space Station to measure carbon dioxide around the globe.
Before she came to NASA to work as an Earth scientist, Anne-Marie wanted to be an engineer.
It's only when I came out to Los Angeles and saw the beautiful smog that was here in the 1980s did I realize, you know what, air pollution is my calling. It felt exciting because it was a tangible problem I could see, and the questions we were going to answer were actually going to make an impact. There's sort of 2 or 3 things that are most critical to the work that we do, and one of those is the measurements from our instrument, from OCO3. What we look at is we see that sunlight is gone through the Earth's atmosphere, reflected off of the Earth's surface, and then comes back to our instrument. And so we measure this amount of light, and every molecule in the world interacts with light in a very unique way. So if you measure the light really carefully, you can learn about how much carbon dioxide was in the atmosphere.
With this technology, scientists can get a deeper look at complex gas mixtures and particles that could be harmful to human health. They can figure out the sources of dangerous air quality and how to improve it. Scientists aren't just interested in surveilling the planet. They want to be able to use the information gathered to look towards the future.
When we think about our Earth and the climate of Earth, we see signs that the climate is changing, but one of the things that's been difficult to do is really predict well what it will be like in 2040 or 2050. So in my mind, when we're thinking about the kids today and what the world's going to be like for them, we want to have some more information to understand that better. And the data we collect is going to help us understand how carbon dioxide flows through the plants and the ocean and the atmosphere. And when we understand more about how it's moving around, we'll be able to tell you more precisely what 2050 might be like.
Understanding Earth gives us the means to better protect it. NASA scientists travel to some of the most dynamic places on our planet to bring back information that helps us understand Earth. And in turn, that information helps us understand our whole universe.
Some of the measurements we can make from space are incredibly valuable, but many other measurements have to be taken on the ground. NASA scientists today are actually spread all over the world. We have a team of people out studying snow in the high mountains in Colorado. We're about to send off a team to the mud flats on the south side of the Everglades National Park to understand how mangroves that were damaged by Hurricane Irma have recovered in the last 2 years. We're sending teams of people to Africa to understand how dust that blows from Africa makes its way all the way around the globe and fertilizes places as far away as the Amazon. My first trip into the Amazon, I remember sort of being overwhelmed, not just by the kind of emotion of arriving finally at the forest frontier, but also kind of the activity. As you step into the forest, you're struck by the fact that the forest environment it's cooler, it's more humid, and it's alive with sounds. You get the chorus and calls of birds and primates, frogs, and other species that just remind you that you're stepping into a world that has thousands and thousands of species, many of which we've not even discovered or described. It's a real sense of awe, I think, that we find in the natural world, and there are many different places you can find it. And so we're in the field with our colleagues making measurements of trees, mangrove roots, of soils and their changes, and listening for sounds, because sounds are another kind of remote sensing that we can make in the location It tells us something unique and different from what we can learn from space. NASA scientists are working really across the globe, and we're using a number of different tools to study our planet and how it's changing.
At NASA, there are actually entire divisions and missions completely dedicated to Earth science. From wildfires to sea level rise, there's a lot to keep an eye on. The data that NASA collects makes a record of our home.
One of the exciting things of working here at NASA is that we have a long record of satellite observations, and that actually allows us to go back in time. So when we think about the ways in which we're studying our planet and its changes, my first thought is we can begin in the 70s or the 80s and start to step forward in time until the present. And that's a really powerful way to look at our planet. And one of the things I think that's a really important foundation for a lot of the work we do going forward is that we do have this long time series of measurements, ice cover, of vegetation, of land use and agriculture, changes in oceans and atmospheric properties. And that long time series really is the basis on which we're understanding the subtle but important changes in our planet.
Before satellites, we knew virtually nothing about the huge ice caps of Earth. Now they've been mapped in incredible detail over several decades. We know more about why Arctic sea ice is shrinking and the loss of water from the Antarctic and Greenland ice sheets. Both of these things are major causes for sea level rise, and we've learned that based on a long record of data.
Over the years, as we've learned to better understand our home planet and to create the kinds of instruments and imaging tools that allow us to take pictures from space of our home planet every day, often more than once per day, we've built really important connections with the farming community, with wildfire and disaster response communities, and a number of other applications that really depend on having information in near real time to respond to ongoing changes. Whether you're a farmer trying to understand whether you need to irrigate or fertilize your field, or you're a firefighter trying to figure out where the next blaze started and how you're going to respond to protect a community in the hills of California. That's where the information that comes in from our satellites today is so valuable for making decisions today. And of course, every day of observations continues our long data record of observations that helps put today's changes in the context of the past.
Doug and Anne-Marie are just two of the many Earth scientists who study our planet each day and monitor its changes.
It's hard not to be overwhelmed by the magnitude of many of the recent changes. Someone who studies wildfire, we're right in the mix of that emotional swirl of wanting to help people in need, of wanting to understand the changes, and as well unable to ignore the consequences of fires, whether they're happening in Australia, the Amazon, or Alaska. Every year from space, we map more than 1 million large wildfires. Every one of those wildfires is important to a community. It doesn't have to be the world's biggest, fastest, hottest, or most extreme fire to be important. I think that's something we always try to keep in perspective. But there are days when it's difficult. It's a lot to manage the emotions of the fact that those 1 million wildfires are doing damages to communities, are changing air quality for people near and far, and are part of the way in which our planet is responding to warming and drying conditions.
You know, by nature, I'm actually a fairly optimistic person. I always somehow manage to find a way to think, well, there's an opportunity for change, an opportunity to advance, and that's the road we're going to take. Certainly when you study things like climate and air pollution, you can see the change over time, and there's some things that we see improving, and there's some things that aren't really improving. But I feel like people are engaged in these questions. They're thinking about the choices they make and the impact it has. So I remain optimistic that people want to learn, they want to understand, and they want to make a good decision in the big picture.
And I think it's important to remember that there are scientists at NASA and really across the world whose primary goal is to keep tabs on what's happening on Earth every day. I think that's reassuring. It's exciting to have a momentous occasion like the 50th celebration of Earth Day, I think to really look back at how much we've learned over those 50 years and how much we have yet to do in terms of our collective action in safeguarding our home planet. It's really exciting to think about what we'll learn and do over the next 10, 20, or 50 years. In a way, it's almost impossible to imagine, and I think that's the exciting part about working at a place like NASA, where we're always thinking about the future and where the possibilities seem pretty endless.
Earth is a truly incredible place, and seeing our planet from space gave us a new appreciation of it. In 1968, astronauts on board Apollo 8 were orbiting our moon when they spotted something incredible on the horizon.
Oh my God, look at that picture over there.
A bright blue marble rising over the dusty lunar surface.
This is Earth coming up. Wow, is that pretty?
That voice? It's astronaut Bill Anders.
Is that a color film, Jim?
He doesn't know it yet, but he's about to take one of the most iconic photos of all time.
Hand me a roll of color quick. Oh man, that's great. Quick.
Earthrise. A reminder that we're all in this together. On this Earth Day, it's important to remember how special our planet really is. After all, we only have one.
It's amazing when you stop and think about it, the variety of life forms that exist and the temperatures that are perfect for us and the way the atmosphere protects us from the UV radiation. I mean, it's really actually pretty astounding that the Earth creates this habitat where we and all the life forms of the Earth can exist. What a wonder.
This is NASA's Curious Universe. The Curious Universe team includes Elizabeth Tammy and Michaela Sosby. Our executive producer is Katie Atkinson. Special thanks to Leslie Mullen, Colin McNutt, Michael Pallas, and Danielle Rappaport. If you like this Curious Universe episode, please let us know by leaving a review or tweeting about the show at NASA. Take a deeper dive by checking out the show notes. Join us next week as we explore a historic NASA mission, the Hubble Space Telescope, our window to the stars.